is Flash Isaac, and I'm a teacher from the future. Indices, logarithm, and sorts. Indices, logarithm, and sorts are very important topics in mathematics because more than 90% of other mathematics topics they depend or they require your knowledge of indices, logarithm, and sorts. Your knowledge of indices, logarithm, and sorts will either make or mar your mathematics career. The reason many persons have problems in mathematics is that they don't have the background or the foundation. What is the background? The background is number and numeration, approximation, percentage, business mathematics, indices, logarithm, and sorts. I will do my best to make sure that you understand or you know what indices, logarithm, and sorts are about. One thing you will notice is that I try to bring all of them together. That is how they are. Indices, logarithm, and sorts are related. You need to learn or practice them together to get the complete idea. Look at something. After solving a mathematics problem or a physics problem, variation question, integration question, or whatever, you arrive at an answer square root of 200. Then you see options. A, 10 root 3. Option B, 10 root 2. Option C, 20 root 3. Option D, 20 root 2. They begin to wonder, what is 10 root 3? What is 10 root 2? Which of them is correct? Especially in a situation where you don't have scientific calculator. What do? That is where the knowledge of indices, logarithm, and sorts come to play. Sorts says if you have the square root of a times b, this is the same thing as the square root of a times the square root of b. We can use this knowledge to get something useful. If the square root of a times b is equals the square root of a times the square root of b, a times b means a is a different number from b. So let's call a 20 and let's call b 5. If you have something like this is the same thing as the square root of 20 times the square root of 5 separately. With this idea, you look at 200. Wow, 200 is 100 times 2. So this is the same thing as the square root of 100 times 2. That is the square root of 200. We did not change anything. 100 times 2 is 200. Getting here, you will be so happy because the square root of a times b, the square root of 100 times 2 is equals the square root of 100 times the square root of 2. What is the square root of 100? 10. So this is 10 times root 2. 10 times root 2 is 10 root 2. You simply say B is correct without the use of calculator or the use of tables. After solving, you got log 2 to base 2. But looking at the options, you are seeing option A 1, B 2, C 3, D 4. Sometimes you feel, I solved wrongly. What's happening? How do I get the answer? And the most painful thing is solving correctly and being unable to pick the right option. From here, looking at the law of logarithm, it says when you have a logarithm to the same base, log of b to base b, its answer is 1. Which means this and this are the same. If you have a logarithm, this and this are the same, then the answer is 1. If you have log 10, the answer is 1. Why? When you don't have base in logarithm, we assume it to be base log 10 because that is the natural base. So log 10 to itself is equals 1. So then after solving, you arrive at this answer. Then looking at the options, you are seeing things like this. what do you do? From the law of indices, we have that if you have s raised to the power of 1 over 3, that is the same thing as cube root of s. Now, 2 raised to the power of 2 over 3 is the same thing as 2 raised to the power of 1 over 3 times 2. Yes, because 1 over 3 times 2 is 2 over 3. From here, when you compare with this, s is 2, 1 over 3, which means here we have cube root of 2. Here is cube root of 2, then raised to the power of 2. Cube root of 2 raised to the power of 2. If you have 2 raised to the power of 1 over 2, this is the same thing as square root of 2. If you have 2 raised to the power of 1 over 4, this is equals the fourth root of 2. If here is 3, here is 3. So, indices and logarithms are very, very important and fundamental. So long you are studying mathematics, you must know them. If you are a physics student, you must know them. If you are studying chemistry, you must know them. Even economics, because all these things, they come to play in any calculation subject. Let's take a look at a beautiful relationship between indices and logarithm. This will make you happy. Yes, look at it. What is indices in the first place? Indices has to do with how many times a number is multiplied, or it has to do with power, exponents. Anytime you are given the number with power, that indicates indices. If you have 2 raised to the power of 3, this is the same thing as 2 into 3 places. 2 times 2 times 2. And what is that? 2 times 2 is 4. 4 times 2 is 8. This is 8. Logarithm simply means how many times one number is multiplied to get another. Take a look at something. Don't rush, don't rush. If I say log 8 to base 2 is equals 3, do you know what this means? This implies that you need to multiply 2 3 times to get 8. Look at it. 2 times 2 times 2 is equals 8. How many times? 1, 2, 3. So you multiply 2 3 times to get 8. Anytime you are given a log question, if I say this log this is equals this, it means you have to multiply this number of times to get 8. And the relationship between indices and logarithm is that in indices, if you have a raised to the power of s is equals y, example, let 2 be a, let 3 be s, is equals y, that is 8. 2 raised to the power of 3 is 8. In logarithm, log a raised to the power of y is equals s. So, log, what is a? 2. Log 2 raised to the power of what is y? 8. 8 is equals s. What is s? 3. 3. From this relationship, it means if I give you log 8 to base 2 is equals 3, it simply means 2 raised to the power of 3. If I say log 2 4 is equals 2, this implies that 2 raised to the power of 2 is equals 4. Log 81 to base 3 is equals 4. This means that 3 raised to the power of 4 is equals 81. So that is the relationship between logarithm and indices. Log 81 to base 3 is 4. It means 3 raised to the power of 4 is equals 81. That is how logarithm work. Now, when you are given a question and they say log 8 raised to the power of 3 to base 2 is equals s, find s, it means that 2 raised to the power of s will give you 8 raised to the power of 3. It simply means that 2 raised to the power of s will give you 8 raised to the power of 3. Is that 512? Now, from here means 2 raised to the power of s is equals 8 raised to the power of 3. It means 2 raised to the power of s is equals 512. Once you have this, do you know the next thing you will be doing? Go to, don't solve, just go to the options. Option A, let if s be 9. If s is 9, will 2 raised to the power of 9 give us 512? Yes. So s is equals 9. If this did not give us, we cancel it. The next option you say, will 2 raised to the power of 8 give us 512? If yes, you pick it. You see? So you'll be able to solve indices and logarithm questions without even solving actually. Now look at this. They say log s squared to base 3 is equals minus 8. Find s. This is the same thing as s squared is equals 3 raised to the power of minus 8. From indices, when you have negative power, for example, a raised to the power of minus 4, it is equals 1 over a raised to the power of 4. This is the same thing as s squared is equals 1 over 3 raised to the power of 8, where a is 3, minus 4 is minus 8. 1 over a, 3 raised to the power of 8. So this means any value you get here, when you square it, it should give you 1 over 3 raised to the power of 8. So this means s squared is equals 1 over 6561. You look at the options. Any of the option, you substitute the value of s and square to give you 1 over 6561 is the correct option. Here, log 280 to base 10 is equals s. It means that 10 raised to the power of s is equals 280. Then you press your calculator. 10 raised to the power of which of the option will give you 280. Anyone that gives you 280 or approximately 280 is the correct option. This is introduction. To solve questions under indices, you need to know the laws or rules of indices. What are the rules to follow when dealing with indices? That is what we shall cover in this episode. The first law of indices is the multiplication law. This law states that if you have s times s raised to the power of m times s raised to the power of n, it is the same thing as s raised to the power of n plus n. Look at it. This is s, this is s. Since they are ss, it simply means that if you have two numbers with the same base, what is here should be the same as what is here. Now let's take s to be any number. Let's say 2. Which means if you have 2 times 2, then this is m, this is m, and m and n means different numbers, which means what is here is not what is here. Let's take here to be 3 and let's take here to be 4. So if you have 3, then we have 4 here. Indices says that this what you are seeing here is the same thing as 2 raised to the power of 3 plus 4. Since the base are the same, you add the power. So 2 raised to the power of 3 plus 4 is equals 2 raised to the power of 7. And 2 raised to the power of 7 is 2 times 2, 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 times multiplying. What does this also imply? It implies that if you have 2 raised to the power of 7, you can simplify it to be 2 raised to the power of 3 times 2 raised to the power of 4. So you can take this to this form or this to this form. So long you didn't change anything, and so long when you punch your calculator, they will give you the same thing. It is very, very valid. And the second law of indices says that if you have s raised to the power of m over s raised to the power of n, this is equals s raised to the power of m minus n. Now here is the interpretation. When you see s in mathematics, or you see y, or you see any alphabet, don't take it to be these persons they've come again. No, they mean unknown. We have many numbers in mathematics: 1, 2, 5, 10, 15, 20. So we cannot give you all the cases. If you are decided to use all the numbers, it means we have more than one. In fact, a lot of laws which you can't follow. So s here and s here means if you have number here and another number here, which means similar number, if they are 100, 100, 50, 50, 25, 25, irrespective of what they are, and the number at the top is raised to the power of something, then the one at the bottom is raised to the power of something else. This will be, take one of the numbers, then you subtract the power. Here, the base are the same. We take one of the base, then we add the powers since we are multiplying. When we are dividing, you subtract the power, which means this is s. Let s be 2. Let's use 2. Or let s be 4 this time around. over, and I have the same number 4 raised to the power of 2. This is the same thing as the base are the same and we have division. We take one of the 4, subtract the powers. You say 3 minus 2. This is the same thing as 4 raised to the power of 1. Most times, you may not get the questions exactly like this, but you see a situation where you have to use different laws to answer a question, which we'll see before the indices, logarithm, and surds aspect is gone. In this episode, the next one, and the next one, we shall continue with indices, logarithm, and surds. So you have enough time and enough videos to teach you this topic. Now, this is what law 3 is trying to tell us. It says that if you have one base now, and that base is raised to the power of a number, and everything is in bracket, then that bracket is raised to the power of another number. Let's call S 5. If S is 5, and M, let's call M 3. If you have 5 to the power of 3, then you have bracket like this. Then another number here, let's call it 2. So this is the same thing as this form. The law of indices says you can simply use the 3 to multiply 2 to give you 5 raised to the power of 3 times 2, and that is 5 raised to the power of 6. That is what indices is saying. By the time you don't leave your number in terms of power, you give your number as a single answer, then you are moving from indices to something else, because indices has to deal with just powers. Then expanding law 3 also say that apart from seeing something like this, 4 raised to the power of 3, let's say 2, to give you 4 raised to the power of 3 times 2 to give you 4 raised to the power of 6. If you have something like this, 2 different numbers, different bases. So let's call the first one 2. Let's call C 3 times 3. Then this one is raised to the power of one number, let's say raised to the power of 1. This one is raised to the power of, let's say, 4. Then everything is also raised to the power of 5. What do you do? The law of indices is trying to tell you that as a bigger boy version of this, yeah, you can use this outside here to multiply each of them. That is what indices is saying. What does that mean? This is same thing as 2 raised to the power of 5, 1 times 5 is 5, times 3 raised to the power of 20. That is what indices is saying. And here also, if you are applying law 1, you can say the bases are different, obviously. So law 1 will not work. Law 1 only works when the bases are the same. So for different bases, you apply this law. And if you have just 2 raised to the power of 1 times 3 raised to the power of 4, you cannot say 2. You cannot do something like this, adding the powers. The bases are different. You only add powers when the bases are the same. Also, an expansion of the law says that if you have A over B, different numbers, let's call it 2 over 3, raised to the power of another number, let's say raised to the power of 4. This is the same thing as using the power to multiply each of the bases. So you can say this is the same thing as 2 raised to the power of 4 over 3 raised to the power of 4. This is very valid. And since the bases are different, you cannot use your division law. You cannot say you are picking 1 and subtracting the power. It won't work. That is interesting law 3. Law 4 told us that if you have A raised to the power of minus 4, this is the same thing as 1 over A raised to the power of 4. This is law of negative power. If I tell you 2 raised to the power of minus 4, this is the same thing as 1 over 2 raised to the power of 4. If I say 3 raised to the power of minus 1, this is the same thing as 1 over 3 raised to the power of 1, which is equals 1 over 3. If I say 5 raised to the power of minus 8, this is the same thing as 1 over 5 raised to the power of 8. What does it mean? So when you mean minus raised to the power of minus something, change the minus to 1 over, then you put what is here under. 6 raised to the power of minus 3 is 1 over 6 raised to the power of 3. That is the law of negative power. Any meaningful number raised to the power of 0, the answer is 1. When we are dealing with number basis, we will tell you that let the powers be descending. Anytime you have a meaningful number that is raised to the power of 0, it is 1. So 2 times 1 raised to the power of 0 is the same thing as 2 times 1. 5 raised to the power of 0 is 1. 10 raised to the power of 0 is 1. Why did I say any meaningful number? Because sometimes you get a situation where you have 0 raised to the power of 0 or infinity raised to the power of 0. So what do you get? What is 0 raised to the power of 0 and what is infinity raised to the power of 0? I'll come back to that later. Then the sixth law says that if you have s raised to the power of 1 over 3, this is the same thing as cube root of s. If you have s raised to the power of 1 over 2, this is square root of s. It implies that anytime I give you square root of s, you can change it to s raised to the power of 1 over 2. Let's change s to a meaningful number. If I say 2 raised to the power of 1 over 2, this is square root of 2. If I say 4 raised to the power of 1 over 3, this is the same thing as cube root of 4. So the one at the bottom form the root, this one will be inside the square root. What if I say 5 raised to the power of 1 over 4? This is the same thing as the fourth root of 5. So this one will be here, this one will be inside here. Then this, the one at the top will be like this. But anything raised to the power of 1, the value remains the same. This brings us to a situation where we need to answer this one. How about you have 5 raised to the power of 2 over 3? How do you answer this? If it were 1 over 3, we will say cube root of 5, right? But since this number is not 1, it is 2. This becomes squared. Everything raised to the power of 2. These are basic laws you should know and you should be able to work with. Indices also says that, okay, this is squared. When you have a over b raised to the power of minus c, this is the same thing as b over a raised to the power of c. Do you know why? If you have a over b raised to the power of minus c, this is the same thing as a over 1. This is the same thing as 1 over a over b raised to the power of c. Because minus raised to the power of minus something will give you 1 over everything there. So this is 1 over a over b raised to the power of c. So when you solve and invert, you get the inverse of it. In practice, if you have 3 over 4 raised to the power of minus 2, this is the same thing as 1 over 3 over 4 squared. This is the same thing as 1 divided by 3 over 4 squared. And when you are changing division to multiplication, you invert what is in the other side. So this becomes, and this is also the same thing as 1 divided by 3 squared over 4 squared, which is 1 times 4 squared over 3 squared. That is 4 squared over 3 squared, and that is the same thing as 3 over 4 squared. Indices is also interesting, and these are the basic rules you need to enjoy mathematics. And a relationship between indices and logarithm is that if you have a raised to the power of log b a, let's say you have 2 raised to the power of log 2, then 3. Something like this. Here and the base here are the same. The answer is simply the power here, 3. If you have 3 raised to the power of log 3, then 4, this is equals 4. Everything here, they go. These are the laws of indices. Now, the first law of logarithm states that if you have log mn to base b or with base b, this is the same thing as log of m with base b plus log of n to base b. This is it. This law is referred to as multiplication law. If you say log 2 3 times 2, this is the same thing as log 2 log 3 base 2 log 3 base 2 plus log 2 base 2. That is what the first law is trying to tell us. This is the law of multiplication. Looking at this law, it simply means if I have log 6 to base 2, I can expand this to be log 2, then 3 times 2, because 3 times 2 is 6. Then from here, I can arrive at this. That is the first law of logarithm, multiplication law. Just like indices says once you have similar base and different powers, you take one of the base, then you add the powers. Logarithm is saying when you have a log to multiplication, you add. So multiplication leads to addition, division leads to subtraction in logarithm. Also, division leads to subtraction in indices. The second law of logarithm says that if you have log, this time around b is the base, so let the base be, let's say let the base be 10, then you have let n be 4 and let n be 5, something like this. So since you have division and you have log to a base, the law of logarithm says that this is the same thing as log 4, the one at the top with base 10, minus log 5, the one at the bottom with base 10. That is the second law of logarithm and the division law. If you have log to base, let's say base 10, the base can be anything, and m raised to the power of k. So what do we call m? Let's call m 5. It can be any number. These values you are seeing, b, m, k, whatever, they mean different numbers. So you can use any number you like or any way they come. If you say m is 5, let k be 2, which means we have log 5 squared with base 10. Logarithm is saying that anytime you see something like this, bring down the power to give you 2 log 10 base 5. So when you have log raised to the power of something, bring out the power. That is logarithm. From this law, I can do something like this. If you give me log 10 25, so log 25 to base 10, since I know that 5 raised to the power of 2 is 25, 5 times 5 is 25, this is the same thing as log 10 5 squared. So I've changed logarithm from this form to this form. So from here, I can also say that this is 2 log 5 to base 10. You see, from the rules, you can expand, you can manipulate, or you can simplify to get what you want. Operations under logarithm require you to simplify, to change, to expand, or to solve so as to get what they require of you. That is simply the logic. And the first law of logarithm says that when you have log 1 to any base, it is 0, which means log 10 base 1 is equals 0. Log 1 base 5 is equals 0. Log 1 base 10 is 0. So log 1 to base anything is equals 0. Then the fifth law says if you have log of a number to its base, which means the number and the base are the same, the answer is 1. What does that imply? If I have log 10 with base 10, this is 1. Log 5 base 5, 1. Log 3 base 3 is equals 1. So in the question or in the equation, I have something like log 6 base 6. I can just simply change this to 1 and start solving. Life gets so easy. And the sixth law or the number 6 law says that if you have log of a base raised to the power of power and the base are the same, the answer is equals k. Grammar, right? This is it. Remember in law 3, we said if we have log, let's say anything here, 10, 5 squared, that this is the same thing as 2 log 5 to base 10. Remember? Law 6 is now telling us that if here and here are the same, therefore if we have log 10 and here is 10 raised to the power of 2, this is the same thing as 2. Okay? So everything, so long here and here are the same, the answer is equals 2. You may be wondering, how? This is the proof. From log 3, if you have something like this, this is the same thing as 2. You bring down the power. 2 log 10 with base 10. Then look at here. From log 5, if you have log to a number with base, if the number and the base are the same, you get 1, which gives you 2 times 1, and this is equals 2, which they are the same. The seventh law is what we already explained under the law of indices, which says a raised to the power of log b over b is equals a. So 2 raised to the power of log b over k is equals k, as seen in logarithm. So 2 raised to the power of log 2 over 5 is equals 5. The first law of surds says that if you have a, let's say a times b is equals to root a times root b. So square root of a times b is equals square root of a times square root of b. Which means if I have the square root of 100 times 2, this is the same thing as the square root of 100 times the square root of 2. The square root of 100 is 10. 10 times 10 is 100. So this is the same thing as 10 times root 2. This is equals 10 root 2. Which implies that if I give you square root of 200 and I say put it in surd form or simplify, since we don't want decimal values, we want very accurate answer. We'll ask ourselves, 200 square root, is this not the same thing as square root of 100 times 2? Yes, because 100 times 2 is 200. This is the same as this, which means this is also the same thing as square root of 100 times square root of 2, which finally gives us 10 root 2. The law of surd, second law, which is the law of division. The first one is the law of multiplication. It says if you have a over b, this is the same thing as square root of a over b, the same thing as square root of a over square root of b. Which means if I have full square root of 10 over 5, or if I have square root of 25 over the square root of 4, this is the same thing as the square root of 25 over the square root of 4. So you break the square root into two, one at the top, one at the bottom, once you have square root of fraction. Now, if you wish to simplify this, The square root of 25 is 5. The square root of 4 is 2. So the square root of 25 over 4 is equals the square root of 25 over the square root of 4, and that is 5 over 2. Then the third law states that square root of a plus b is not the same thing as square root of a plus square root of b. In the law of multiplication, we said the square root of a times b is equals the square root of a plus the square root of b, but times the square root of b rather. But if it is addition, the square root of a plus b is not equal to the square root of a plus the square root of b. So if I give you square root of 5 plus 6, this is not square root of 5 plus square root of 6. That is not the case. You can actually say square root of 11, correct, but don't break it down this way. And the next one says, we've been told that if you have this over this is the same thing as square root of 25 over square root of 4. But when it comes to subtraction, the square root of 5 minus 6 minus 4, for example, it is not equals the square root of 5 minus the square root of 4. Under addition and subtraction, don't break the square root into 2. It is not correct. And the next one says, or the fifth law of surd says that when you have square root of similar number, the answer is the number. Square root of similar numbers will give you the number. Square root of 5 times square root of 5 is equals 5. Square root of 20 times the square root of 20 is equals 20. Square root of 10 times the square root of 10 is equals 10. Square root of 500 times the square root of 500 is equals 500. Ladies and gentlemen, by now we've learned a lot of skills, or we've acquired a lot of skills to reason well when it comes to indices, logarithm, and surds. From law 6, it says the cube root of s is the same thing as s raised to the power of 1 over 3. So the cube root of 4 raised to the power of 2s is the same thing as 4 raised to the power of 2s raised to the power of 1 over 3. They say this is equals 16. So equals 16. If this is equal to 16, Indices also said that if a number is raised to the power of 1 power and another power, multiply the powers. So this is the same thing as 4 raised to the power of 2s times 1 over 3. This is equals 16. This is 4 raised to the power of 2s over 3. 2s times 1 is 2s over 3. So this is equals 16. And in indices, one thing you are required to know, or one skill you must know, or something that you keep bringing in your mind, is how to make the bases the same. Because once you are able to make the bases the same, you just equate the powers and solve and get the correct option. That is the same thing that is required in logarithm. You look for ways to make the bases the same, or to solve, to simplify, to get what you are supposed to have, or what they want you to get from the options. You know what they are expected, or what is expected of you. From here, I know that 4 is 2 raised to the power of 2, because 2 times 2 is 4, which means I've replaced 4 with 2 raised to the power of 2. If I replace 4 with 2 raised to the power of 2, it means I still have 2 raised to the power of 2s over 3. Here and here, I did not change anything. And 16 is 2 raised to the power of 4. I didn't change anything. What is 2 raised to the power of 4? 16. What is 16? 2 raised to the power of 4. So I didn't do much, and I don't think I did anything wrong either. From here, I say that 2 raised to the power of 2 raised to the power of 2s over 3 will multiply the powers to give me 2 raised to the power of 4s over 3 is equals 2 raised to the power of 4. Indices says when the bases are the same and there is equal to here, it also means that the powers are the same. We equate the power to have 4s over 3 is equals 4. And 3 times 4 is 12. 4s is equals 12. S is equals 12 over 4. That should give you 3. So the value of s is 3. And look at it. If you put s to be 3, 3 times 2 is 6. 6 divided by 3, that is 2. Which means everything here will be 4 raised to the power of 2. And 16 is also 4 raised to the power of 2. You see, you get the answer. When you are given questions like this, just go to the option. Substitute each of the value of s they give you in the options. Anyone you substitute on the left hand side to give you the right hand side, it is the correct option. So most times, you don't even need to solve questions under these areas. Just substitution and a little touch of common sense is what will do the magic for you. In this question, you have 9 raised to the power of 2s minus 1 over 27 raised to the power of s plus 1 is equals 1. Which of the option would you put s to be? If they say A, s is 2, B, s is 3, whatever, substitute the value of s in the option into here and here. If you simplify here using the value of s given or using the options, anyone that gives you 1 is the correct value of s. But if you wish to solve the normal way, this and this, we know that from the law of division, if we are able to make the base the same, then we can subtract the power. So one of the skills you need in indices and logarithm more than 90% of the time is doing everything possible to make the bases the same. Because when the bases are the same, we can equate the powers, add the powers, or do whatever we want to the power. Life becomes so easy. But solving with different bases is more difficult. So from here, we know that 9 is 3 raised to the power of 2. So if 9 is 3 raised to the power of 2, here is 9, then we have 2s minus 1. Then over 27 is 3 raised to the power of 3. 3 times 3 is 9 times 3, 27. So this is 3 raised to the power of 3 here. Then we have s plus 1. 3 raised to the power of 3, 27. 3 raised to the power of 2 is 9. So if you're able to arrive here, and from the law of indices, if a number is raised to the power of 2 powers, you can multiply the powers. So this is the same thing as 3 raised to the power of 2 times 2s, that is 4s, minus 2 times 1, 2. You use 2 to multiply everything here, over here, 3 to multiply s, 3s, plus 3 times 1 is 3. Everything is equals 1. If you look at this part, the bases are the same. Here is 3, here is 3. From here, you can subtract the powers. Pick one of the 3, subtract the powers. So 4s minus 2 minus bracket 3s plus 3. This is equals 1. Your addition and subtraction skill is very important here. Because if you say minus without bracket, you may arrive at a wrong answer. So this is 1. You ask yourself, here is 3. How do we change 1 to 3? Remember, your skill or knowledge of making the base different, the same, is also important. Since 1 is a single number, we know that any meaningful number raised to the power of 0 will give you 1 from law 5. Which means 3 raised to the power of 0 is the same thing as 1. If I change this 1 to 3 raised to the power of 0, I have not done anything wrong, because this is also the same as 1. So from here, the base are the same. Then we equate the power to have 4s minus 2 minus times 3s minus 3s minus times 3 minus 3. Everything is equals 0. Collecting like terms, 4s minus 3s is s is equals minus 2 minus 3 is minus 5. Moving to the other side, we have 0 plus 5. So s is equals 5. So sweet. There are many ways you can solve it, because if you know all the laws of logarithm, you can solve questions the ways you like. But this is how I will solve questions like this. And all the questions under indices and logarithm, they revolve around your ability to apply the laws in the forward direction and in the reverse direction. In the forward direction, you know that if I give you log 3 18 times 3, this is the same thing as log 3 18 plus log 3 3. From the law of first law, log m times n to base b. So log m, let n be 3, let n be 18, let n be 3. Base, let base be 3. So logarithm says that if you have this is the same thing as this. What does that mean? It means if you have something like this, log 18 with base 3 plus log 3 to base 3, this is the same thing as log 18 times 3 to base 3 from the law of logarithm. I did not change anything. I just remembered the law. That's all. If that is true, it means that instead of here, I can replace it with log 3 18 times 3 to base 3. Then here becomes minus log 3 s is equals 3. From here, I can as well apply the law of logarithm. Anytime the bases are the same, just know that the question is not as difficult as it seems. From the law of subtraction, it says if the bases are the same, and two numbers are separated by minus, you can divide. It is simply log to base, which is one of the bases, 3, then the powers, 18 times 3 over s. So this is equals 3. That is the law of logarithm, subtraction law. You may say here is just one number. Of course, 18 times 3 will give you a single number. From here, you ask yourself, what do I do? If you don't study to forget, and you remember where I gave you the meaning of indices in the first part of this indices, logarithm and surds, I said that anytime you have log to a base is equals a particular number, it means that this raised to the power of this is equals this from the very first introduction. So 18 times 3 over s is equals 3 raised to the power of 3. That is the relationship between indices and logarithm, which means 18 times 3 over s is equals 27, which is cross multiplying 18 times 3 over 27 is equals s. 3 into 3, 1. 27 into 3, that's 9. 9 divided by 9, 1. 18 divided by 9, that is 2. So 18 times 3 over 27 is equal to 2. So the value of s is equal to 2. Given log 2 to be 0.3010, log 7 to be 0.8451, evaluate log 112. Since there is no base, this is the same thing as log 112 with base 10. That is what they are trying to tell us. Now, this is the same thing as log 10 112. Fine, the answer is equals s. On a normal day, this is the same thing as 10 raised to the power of s is equals 112. But look at the skill they are trying to get from you. Without table or chair or calculator, whatever, if they give you log 112 and they already told you what log 2 is and log 7 is, it means get 2 and 7 from 112. That is the logic. Get 2 and 7 from 112. If you're able to do that, then you are smart. Another question comes to mind. How do we get 2 and 7 from 112? If you understand how to solve quadratic equation using factorization method, you will be told to look for two numbers that when you multiply, you get a particular number. So, can we get two numbers that when we multiply, we'll get 112? So, can we multiply 2 and 7? Or how do we get numbers that are 2 and 7 multiplied to get 112? If you have something like this, log 16 times 7. 16 times 7 is 112. But we have 2. We have 7, we don't have 2. Can we get 2 from 16? Of course, we can, and we've been doing that since. So, this is something as log 2 raised to the power of 4 times 7. And from the law of logarithm, it says if you have multiplication, this is something as log of the first part plus log of the second part. Square root of 162 is the same thing as square root of 81 times 2. And according to the law of surds, this is the same thing as square root of 81 times square root of 2. And according to division, the square root of 81 is 9. So this is 9 times square root of 2 is equals 9 root 2. So that is square root of 162. The next one says we should simplify root 3 plus 3 root 3 plus root 5 plus 3 root 5. 3 root 3, 3 root 5. This is the same thing as 1 root 3. And this is the same thing as 1 root 5. So, in surds, if the square roots are the same, we can actually add the values outside the square roots. In other words, this is how to do addition of surds. So long the roots are the same, we can say 1 plus 3, 4 root 3. So you add the outside one, then you take one of the roots. Because root A plus root B is equal, root A plus root A is equals root A. And root A times root A is equal to A. Please take note of that. Plus 1 root 5 plus 3 root 5 is 4 root 5. Now, we have 4 here, we have 4 here. We factorize, bring out one of the 4 to get 4 root 3 plus root 5. And according to the law of surds, if you have root A plus B or root A minus B, it is not the same thing as multiplying or separating them. You end it like this. There is nothing else to do. So this is the answer to that question. This is under multiplication of surds. The way you multiply surds is the way you do normal opening of brackets, which means you use root 3 to multiply root 2 plus root 3. Now, here is plus 2. So, plus 2 to multiply root 2 and root 3. That is basically it. Root 3 times root 2 is root 6. When you are multiplying surds, inside times inside, and the square root remains the same. Plus root 3 times root 3 is equals 3. According to the law of surds, root A times root A is equals A. When you have the same square root, as you multiply them, the square root vanishes. You now have one of the numbers. Plus 2 times root 2, that is 2 root 2. Plus times plus 2 times root 3, 2 root 3. From here, there is no like term to collect, nothing to add, nothing similar. So we have to leave the answer that way. And the last question for this episode says root 12 minus root 3 over root 12 plus root 3. When you have division of surds and there is addition or subtraction separating them, the best thing you do is to rationalize the surds. How do you rationalize? You multiply the numerator and the denominator by the conjugate or the inverse or a negative form of the denominator. Leave grammar. If you have something like this in any surds, two numbers here, you rationalize. How do you rationalize? This is the denominator. You write it here, root 12. Instead of plus, it becomes minus root 3. If it's a minus, you turn it to plus. That is it. Over the same thing, root 3. Where does this lead you to? It leads you to multiplication. So we are using this to multiply this, and we are using this to multiply this. This to multiply everything here, minus root 3 multiplying everything here, over 12 times root 12, and also 12 times minus root 3, plus root 3 times root 12, plus root 3 times minus root 3. So these are the basic operations. Root 12 times root 12, you get 12. The square root of 12 times minus square root of 3 is minus square root of 36. So from here, square root of 36 is 6. Square root of 36 is 6, giving you 12 minus 6 minus 6 minus 3. And the bottom here will give you 12 minus 3. So everything simplifies to 3 over 9. So that make S the subject of the formula. We are given 7 is equals 2 raised to the power of S minus 1 plus 3. And make S the subject of the formula. This is change of subject formula equation leading to indices. From here, if we collect like terms, we shall have 7 minus 3 is equals 2 raised to the power of S minus 1. 7 minus 3 is 4. So 4 is equals 2 raised to the power of S minus 1. In indices, we try to make the base the same so that we can equate the power. Make the base the same so that operations can be easy for us. If we do that, this becomes 2 raised to the power of 2 is equals 2 raised to the power of S minus 1. Because 4 is the same thing as 2 raised to the power of 2. Now the bases are the same. It therefore means that the power can be equated. So this is 2 is equals S minus 1. Since 2 is equals 2, the 2 at the top is equals S minus 1. From here, 2 plus 1 is equals S. 3 is equals S. And S is equals 3. Option A is the correct option. And here it says, if log 2 with base 10 is equals 0.3010, and log 7 with base 10 is equals 0.8451, evaluate log 280 with base 10. This is the task before us. We've solved questions like this before. That was where we said log, was it 4 times 7 to give us a particular number? No, log 16 times 7 to give us a particular number. So in this case, we are given log 2 and log 7. How do we get 2 and 7 from 280? Either directly or in a simplified form. Ladies and gentlemen, what is 4 times 70? 4 times 70 is 280. If you agree with me, it simply means this is the same thing as log 4 times 70 with base 10. In logarithm indices and surds, there is no fixed way of solving. Based on how the question comes, you just look for a way to simplify from the laws, from experience, and from reasoning. Experience especially. Now that you've seen that previous question and you've seen this question, if you see questions like this, you always know what to do. Your reasoning will go there. This is why you must follow the episode, get the Flatteners Jam app, activate, and solve similar questions. So now, look at this. From the law of logarithm, if you have this log to base a times b, log to base a times b. This is the same thing as log to the base plus log to the base of the second number. From here, this is the same thing as log 2 raised to the power of 2 with base 10. You can see that we've been able to bring out log 2 with base 10. Plus, here, we cannot bring out 7 directly. We cannot say 7 raised to the power of something to give us 70. However, we know that log 10 to base 70 is the same thing as log 10 to 7 times 10. So log 10, 7 times 10 is the same thing as log 10 to base 7. So this is this multiplication law. If this is this, and from the law of logarithm, if you have log base m raised to the power of k, you bring down the power. Bringing down this power, we have 2 log 10 base 2 plus, reapplying the law, this is the same thing as log bm plus log bn. So here is the same thing as log 7 to base 10 plus log 10 with base 10. With this, food is ready. Why did I say that food is ready? Because log 10 to base 10 is 1. Any log raised to the base, if the base and the numbers are the same, then you get 1 as the answer. And we have log 2 with base 10 already given. We have log 7 with base 10 given. We simply substitute to have 2 times log 2 to base 10, they said 0.3010 plus log 7 to base 10, they said 0.8451. Then plus log 10 with base 10 is 1. So if you do this operation, you should be able to arrive at 2.4471. 2 log 9 with base 3 times log 81 raised to the power of minus 2 with base 3 over log 625 with base 5. It looks complex, but it's something you can solve easily. Log 9 with base 3 times log 81 raised to the power of minus 2 base 3 over log 625 base 5. From here, we know that if we are able to make the number here and the base the same, life can get very, very easy for us. What do I mean by that? This is the same thing as 2 log 3. 9 is 3 raised to the power of 2. We've not changed anything. And this is the same thing as log 3. Before then, from here, if you have log to base to another number raised to a power, or you have log raised to any power, we can bring down the power to give you minus 2 log 381 over 5 raised to the power of 4 is 625. So log 5 raised to the power of 4. Look at a hint. If you have a base and a base and a base, bring your calculator. The base begin to punch. Like here is 3. Say 3 times 3 equals. If it doesn't give you what is here, cancel. Enter 3 times 3 times 3. So see if you multiply 2, 3, 4, 5 times, whether you get what is here. If you get it, fine. Like in this case, there is 5 here. We know that we are trying to bring out 5 out of here and power. On your calculator, punch 5 times 5, 25. No, cancel. Press again. 5 times 5 times 5. That is 3 times. See what you get. Cancel. Press again. 5 times 5 times 5 times 5. So if you keep trying and it's approaching the number here, you know that once you try 4 times, you get 625. Therefore, 625 is 5 raised to the power of 4. That is the trick. So this is, here now, there is power here. we also bring down the power as the log. So to give us 2 times 2, this becomes 4 log 3 with base 3 times 81 is 3 raised to the power of 4. There is 3 here. Just say 3 times 3 times 3. You get 81. So here is 3 raised to the power of 4. Okay. Log 3 raised to the power of 4 over here. Bring down the power. So 4 log 5 with base 5. From here, when you bring out the power here, you have minus 2 times 4. 2 times 4 is 8. So this is minus 8. Food is ready. If the log and the base are the same, that will give you 1. So log 3 to base 3 or with base 3 is 1. Log 3 with base 3 is 1. Log 5 with base 5 is 1. So 4 times 1 minus 8 times 1, 4 times 1. To give you 4 times minus 8 over 4. That will give you minus 8. Option D is the correct option. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.